Now we're going to do something a little bit different. This time, instead of having the angle and finding the function value, we're going to go backwards. So we're going to have a function value, and from that we want to find an angle. In this problem, we're trying to find all possible values of theta if theta is between 0 and 360, and we have this value for the cosine. And here where it says all possible values of theta, it depends on what interval they give you. This time it's looking between 0 and 360, and it's possible there might be more than one solution for theta. In fact, in most of these, there's going to be more than one solution. First, we need to find a reference angle that has the positive function value, which would be cosine of theta prime equals the positive square root of 2 over 2. We want to find what angle this would be. So the angle in the first quadrant that has this value for the cosine would be 45 degrees. All we're doing here is taking those function values and going backwards from the function value to the angle. Now we want to know where that would have a negative function value. So we want to think about what quadrants cosine is negative in. That would be quadrants 2 and quadrants 3. Here we've got our reference angle of 45 degrees. We want to figure out what angles correspond to that are in quadrant 2 and quadrant 3. In quadrant 2, we'd have our original angle theta plus our reference angle would have to add up to 180. So for that one, we'd have theta plus 45 degrees equals 180 degrees. And if we solve that for theta, we get 135 degrees. So that's a second quadrant angle. For quadrant 3, we'd have 180 degrees plus our reference angle, and that would add up to our angle theta. So in that one, our equation would be theta equals 180 plus 45, and that would give us 225. That would be our third quadrant angle. So these are our two solutions for theta. One more example of this. Now for me, anytime that I have one of the three reciprocal functions, I almost always flip that over and use one of the original three functions, sine, cosine, or tangent. So here where I've got cosecant, I'm going to flip that over so that I've got sine. So if I flip that over, I've got 3 over 2 times the square root of 3. If I rationalize the denominator of that and simplify it, that gives me the square root of 3 over 2. So I know my sine of theta is going to be the square root of 3 over 2, and I'm looking for theta. The angle in quadrant 1 that has this value for sine would be 60 degrees. So that's my reference angle. And I know sine is positive in quadrants 1 and 2. It means cosecant's also positive in quadrants 1 and 2. So I already have the quadrant 1 angle. That would be the 60 degrees. In quadrant 2, my angle plus my reference angle is going to be 180 degrees. If I solve this equation for theta, I get 120. That means that my two solutions for this problem are 60 degrees and 120 degrees. One last thing to talk about for this section, and that is how to find angle measures using your calculator. And again, this is if we have the function value and we're trying to find the angle. As long as x is in the range of our function, we're going to use the inverse sine of x, or the inverse cosine of x, or the inverse tangent of x. And these are all functions that are on your calculator. What these do is, where the x is the function value, then this function is going to give you back the angle. Now the important thing to remember here is that this is not the same as 1 over sine of x. 1 over sine of x is cosecant of x. That's not saying the same thing here. The inverse sine of x means we're using an inverse function. It's the inverse function of sine. And that means that we're given the function value and it gives us back the angle. So it reverses what the sine function does. So these are just like the problems we did before, only these angles aren't necessarily going to be our special angles. So here we pretty much have to use the calculator. And this time our interval is only between 0 and 90 degrees. So it's a first quadrant angle. If we have sine of theta is 0.8261, then one way we can think about this, the inverse sine, we can use that on both sides of the equation. And then since these two are inverses of each other, they cancel each other out. That would give us just theta on this side of the equation. And over here, we've got inverse sine of 0.8261. For that, we're just going to plug it into our calculator. First, I'm going to make sure my calculator is in degree mode. Yes, it is. What I'm going to use is the inverse sine function, which is right here above my sine. To get that, I'm going to do second and the sine button. That does sine inverse, and then I'm going to put in my 0.8261. And there's my angle, and that's automatically given in decimal degrees. If I wanted to change it to degrees, minutes, seconds, I could do that like we talked about before. But this gives me, rounded to 1 decimal place, it would be 55.7 degrees. Now for this problem, again, this isn't one of my 3 main trig functions, so I'm going to use a reciprocal identity to change this from cotangent to tangent. Tangent is equal to 1 over cotangent, so I'm going to take 1 over this value to get the value of tangent. That means tangent of theta is approximately 0.212558. Now I'm taking this equation and I'm going to use the inverse tangent function on each side. So over here I've got inverse tangent, and over here I've got inverse tangent. Then these two are inverses of each other, so they cancel each other out. That gives me just theta on that side. So on this side I have the inverse tangent of this value. I'm going to use second and the tangent key to get inverse tangent, and then I'm just putting in that value. And I get 12 degrees. If I round that to 1 decimal place, it's 12.0 degrees.